What's happening, dogs? Mr. Allen here. We are about to determine if these functions that we have here, these exponential functions, are either exponential growth or exponential decay. Now, the first thing that we look at would be our base. Our base is the number that is being raised to our exponent. Now, if that number is between 0 and 1, then we know we have a decay function, and if it's greater than 1, we know we have a growth function, unless we have some transformations that we need to take into account, which we will in one of these 6 examples, or maybe 2 of them. Ooh, we'll see. All right, so the first one here, relatively straightforward. Our base that is being raised to our exponent is 1/2, which is between 0 and 1. This number out here does not play into whether it's a growth or decay. All right, so since this 1/2 is our base being raised to that x, this means that it is a decay function. All right, next one here, g of x. We have number 2 being raised to the x plus 1, and then we have minus 4. The plus 1 and the minus 4 are just transformations. It's going to shift that graph to the left 1, and it's going to go down 4. But that does not play into the role of growth or decay. Since this number here, my base being raised to the exponent, is greater than 1, we know we have a growth function. We are cooking, dogs. Now this next one here, we got 1.4. That is greater than 1, right? So then you would think it's a growth function. But this negative up in the exponent, in the function, is going to give us a horizontal reflection. So normally, this guy here without that would be looking like this. But if I reflect that horizontally, and this would be like our x-axis, or sorry, our y-axis and our x-axis. Now, if I reflect that, okay, if I reflect that horizontally, now my graph is going to look more like that. Should have gone through the same spot. There we go. All right, so now I'm going to have a decay function. So this one's going to be decay. So if you want to like kind of generalize things, if I have that horizontal reflection there, now it's flip-flop, okay? Because it's going to be going down and to the right instead of up and to the right with that horizontal reflection. So horizontal reflection with that base being greater than 1 is going to result in a decay function. If you're a person that likes to remember those certain things, that's something you could jot down. All right, next one here. We have what would look like a decay function, right? It's between 0 and 1, right? Notice how we're not saying less than 1, right? It's between 0 and 1. Because once these numbers get negative, it's something totally different. All right. So between 0 and 1. So we're thinking decay, right? But our graph would look something like this without this negative exponent. It would normally look something like this for a decay function, right? But because that negative happened, this graph now reflects horizontally over that y-axis. And let's see if I can get it better this time. Yeah. Same y-intercept, right? Now it's going up and to the right due to that horizontal reflection. So this one's going to be a growth function. Growth. All right. Next one here. That 1/3, just out front, right? It's going to be a vertical compression by 1/3. This 6 here is my base. That's greater than 1. So this is going to be growth, no negative exponent here. And then over here, I have 5/4. Usually we think fractions. That's going to be like decay, right? But 5/4 is greater than 1. And I have an x for my exponent, right? No horizontal reflection or anything like that. So this is going to be growth as well. That -3 is just going to shift the graph down 3, not going to play into the growth or decay aspect. All right, 2 decays, 4 growth. That's dope. You're dope. Awesome.